In this tutorial, we will talk about JSON Web Tokens and how to use it for authentication and authorization in Spring Boot application. So in this tutorial, we will start with the basic idea of JSON Web Tokens, also known as JWTs. We will see how it works and what is its basic ideas. And then we will discuss a sample project that we are going to use for this tutorial. I have already prepared a bare minimum project that do not have any JWT authentication and authorization enabled. So we will familiarize with that code first, and then we will work on generating new JWTs for a user after logging in. And then we will see how to use that generated JWT for further authorization for getting access to restricted endpoints. And then in the end of this tutorial, we will talk about the different signing algorithms available for JWTs. So we will compare the different algorithms available and then finish the tutorial. So without further ado, let's get started. Let us first understand the basic idea of JWT. So here you can see there is a user and a Spring server or Spring Boot server. And the first thing the user will do is log in with a username and password. So the user will be having a username and password issued to them, and they will use that username and password and make a login request. When the server receives that request, it will generate a JWT token or JSON Web Token using a secret key that is only known to the Spring server. So there will be a secret key stored in the server, and with the help of that secret key, after validating the user's login username and password, it will generate a JWT key. Then that key will be returned to the user. Now the user have the JWT token with a certain validity, let's say for 30 minutes or 1 hour, and the user can use this JWT for further requests. For example, if he want to access some specific data from the server that is only allowed for logged in users, he can make that request using this JWT token. So I will just recap this once more. The user will initiate a login procedure using his own username and password. Then if it is a valid one, the Spring server will create a JWT token and return it back to the user. And for all subsequent requests, this JWT can be used as a passkey or an access key to authenticate and authorize with the Spring Boot server. So that is the very basic idea. Now let us have a look at an example JSON Web Token. So I told you that we need a secret key. The secret key will be only known to the server. So this is an example secret key. So whenever a login request comes, if the credentials are valid, a JWT token will be created using a secret key like this. And this is an example JWT token. When you look at the JSON Web Token, it might look like a random alphanumeric combination, but that is not actually the case. There is a website called jwt.io. It's an online tool which allows you to paste a JSON Web Token, and it will actually give you the information about the JSON Web Token itself. So here I have copied my key, the sample JWT token, and pasted here. And here you can see some interesting information. So the first thing is the algorithm used to prepare this JSON Web Token. And as you can see here, there are a couple of algorithms supported. At the end of this tutorial, we will be discussing the difference between each of these tutorial. So for now, just understand that this is an algorithm used along with the secret key to prepare the encoded JSON Web Token. So this is the algorithm. And then there is a payload data. And the payload data contains the information stored within the JSON Web Token itself. So the good thing about JSON Web Token is that it can contain payload data like username, or maybe if there is a role like admin, user, etc. roles, that information can be stored. If you have any custom data that you want to store, that also you can store it here. So in this example, I have included an ISS, which is who is the issuer of the JSON Web Token. This is a custom field I have added. We will do that in this tutorial. So you will see how to add that. So the good thing is here you can add payload based data. So you might not have to do database operation to authenticate with the JWT tokens. And then there is a verify signature. This is the interesting part. If you look at here right now, it shows invalid signature because I haven't provided any secret key here. So JWT can be validated by entering the secret key. So if you look at here, you can see we have a secret key, and this secret key is only known to the server. If you have the secret key, you can paste that here and validate the correctness of the JWT token. That is needed because if someone gets access to this token and change some data, for example, this IAT is like when the token was issued, and EXP is the expiration time, like when the JWT will expire. Let's say some hacker got access to the key and change it and want to change this to some other value like 529, something like that. Then the whole encoded data will change and they won't be able to sign it because the signature secret is only available to the issuer, which is our server. So let me do one thing. Let me copy the key and paste it here. So I am pasting the secret key here, and you can see signature is verified here. So that is the basic idea of JWT tokens. Now let us come back to our slide and have a look at another workflow diagram. So the idea here is like this. First, when the login is attempted, the header plus payload information along with the server secret key will be used to generate a JWT token, right? So the header and payload and secret key will be signed using the algorithm, and then the JWT will be created and given to the client. Then the client will use that JWT key for further access to the server. And when that key is received, the header and payload will be extracted from the key, and the server's secret key will be used to test that signature. So the signature will only be valid if it was like created by our own server, because without the secret, the signature cannot be created. So that's the basic idea. I hope it is clear. If you have any confusion, don't worry. It will become very clear as we start our coding. Now, let us discuss the structure of the basic project I have prepared for this tutorial. I am not creating a new project from scratch to save some time, and I have already covered the entire Spring Security Framework tutorial in another tutorial video. So if you know the very basic ideas of Spring Security, then you can continue on this tutorial. You don't have to worry about anything. But if you don't know anything about Spring Security, please have a look at my previous video on Spring Security. I will leave the link of that video in the description. So the basic idea of Spring Security is required. So the structure of this in this project, we will have three endpoints. One is /home, one is /user/home, and /admin/home. And all these endpoints are protected based on the role. So the first one is not protected. The /home is accessible for everyone. Any user without login can access the /home. And the /user/home endpoint is accessible to a user. So the user, any user with a user role will have access to the user home. The /home is accessible for everyone, and the admin/home is accessible for admin user only. So the admin can access the other two along with the admin. The user, normal users can access the user home along with the /home, like that. So this is the basic authorization requirement for this project. Now let us have a look at the code and understand what is done in the project. Let us first have a look at the dependencies used in this project. So this project have Spring Boot Starter data dependency for storing the users in the database. It has Spring Boot Starter web dependency and Spring Boot Starter security along with a MySQL connector so that the database connections can be made. And in the application.properties, there is nothing new. We have the required username and password declaration for the database, the URL of the database, and the Hibernate related queries, Hibernated related settings here. And then this is the main class, JWT application. There is nothing extra there. Regarding the user, we have a my user class. And here I have 4 fields. The first one is the ID, the primary key. And the username and password of the user will be stored in these fields. And regarding the role, as we have just discussed, we have 2 roles. One is admin and one is user. So the role field, the role information is stored in this role field. And this is a simple Java Pojo class. And in the My User Detail service, we have a function to load the user by username. So we have covered this also in the previous My Spring Security tutorial. So this is for automatically authenticating after providing a username and password in the login screen. So by giving a username, we will find a user with that username, and then we will validate them and provide to the authentication module. And then we have the basic repository as well. And in the content controller also, there are 3 endpoints like we have discussed. We have /home, /admin /home, and /user /home. And the authorization controls, the restrictions are provided in the security configuration. So here we have restricted that the admin, anything that starts with admin should be accessible to admin users only. Anything that starts with user should have the role user. And then we have linked the database based authentication here through this authentication provider. We are using the bcrypt password encoder, and we have the basic CSRF disabled and those kind of things. And the last thing here I have to show you is the registration controller. So when we want to create a new user, I can make a register /user request and it will log in. Now let us start our coding for JWT implementation. So the first step of JWT integration is creating or generating a new JWT when the user makes the login. So when the user tries to log in using the username and password, we have to validate the username and password, the credentials, and then create a JWT and return the token back to the user. So that is the first step. So to support JWT, we have to add 3 libraries. So these are the libraries we need to add. The first one is io.json web token JWT implementation, then JWT API, then JWT Jackson. So this is the API, this is the API's implementation, and this is like for supporting JSON schema and those kind of things. So I will add these one by one. So JWT API. So let me take 0.12.5, then copy this. So I will go into the build.gradle and I will add it here. So the first thing I need to add is JWT API, and then I need to add JWT implementation, IMPL, and then I need to add JWT Jackson. So these are the 3 libraries I need to add. And then let me refresh the refresh the Gradle project so that the dependencies are properly loaded. Okay, that is complete. And now what we need to do is we need to create a service class for managing the JWT operations. So for that, I will create a new package here, then call it as maybe web token. And then I will create a new Java class called JWT service. So in the JWT service, we'll be doing all the JWT related tasks like issuing a new JWT token, validating it, etc. So the first thing we need in the JWT service is the secret key. We need to have the secret key for both generation of the JWT as well as for the validation. So to generate secret key, you can do that in the Java code itself. It doesn't have to be in the JWT service because it is a one-time process. You generate the key once and use it as a secure key in the code. So to generate the key, I will use a test code. So I will go into the test section and create a new Java class, and I will name this as JWT secret maker, something like this. And then I will create a test function. So at test public void generate secret key. Okay, so we will create a secret key here like this, and then to create the secret key, the library we added, the libraries we just added, it provides support for the secret key generation as well. So for that, there is a class called JWTS, and here we have to choose the SIG option, and then you have to choose the signature algorithm. So there are many algorithms, and I will be explaining the difference between all of these algorithms at the end of this tutorial. So if you are interested about it right now, just go to the end of this tutorial and see the explanation. So basically these are different kinds of algorithm. Each has its own advantages and disadvantages. The most common one available is called HS algorithms. So the HS has three variations: HS 256, 384, and 512. And the fastest one is 256 because obviously the length of the key is a number. So HS 256 has like a key length of 256 bits. So I'll be using the secure one, HS 512. So then we have to use key.build. So this will give me a secret key. Secret key equals. Okay, so we have the secret key generated. Now we have to convert that into a string value. So the data type converter dot print hex binary, and here we can give key dot get encoder. So this class, the data type converter from Jakarta XML bind, provide a function called the print hex binary that will convert the encoded byte array into hex format. So this is the key we are interested. So key. Then I will just system.out.println here. So key encoded, or maybe encoded key. Then I will print it here. So key equals %s. So printf /n like this. Then I will print the encoder key. Now let me run the code. There is like a small warning because I am not naming it as test. So JWT secret maker test, because test classes are supposed to end with the word test. Now let me run the function, generate secret key function, and it should give me a secure key. So here you can see we have our secret ready. Now I will copy the secret and come back to the JWT service and use that value as the secret key. So in the future, for your production, if you want to create another key, you can just run this function again and it will create another secret key. So here I will provide public static final string secret equals our secret key. So the secret key is added here. I will make it as private. And the next thing I need to do is to generate a token. So the first, I will start writing a function. So first we need to generate a JWT token. So the JWT token is going to be in a string format. As you have seen, it is just an alphanumeric string. So public string, and then we will provide the function generate token. And for generating the token, we need a user, right? We will generate the token for each user after they log in. So I will provide user details here. So user details. And here we have to write our code to generate the tokens. So let us start writing like this. So JWTS, we will be using the same class we used to prepare the secret key. So JWTS dot builder, and then we have a couple of options to configure here. So the first thing we need to configure is the subject of the token. So the subject is going to be the user. For which user we are generating the token, that is the subject. So for that, we will use user details dot get username. So the subject is set. Now we need to set the issued at. So the issued at points to when the token was issued or generated. So that is going to be the current date and time. That can be done like this. So date from and instant dot now. So that will use the current date and time as the issued timestamp. Then the most important parameter is the expiration. Like each JSON Web Token have an expiration. For example, if you set 30 minutes as the expiration, then after the issue, you can use the same token for 30 minutes. But after 30 minutes, the user will have to make another login request and get the token issued again. So expiration is very important. So I will extract, or I will create a another variable here, global variable here. So private static, maybe final long. So the duration or validity, so how long it is valid. So that for now, for testing, I am setting time unit maybe minutes to millis. So I will set 30 minutes here. So what this means is this will convert 30 minutes into milliseconds, because we have to provide that here. So here date from instant.now plus millis, and here I can give like number of milliseconds I want to add, and I will give the validity here. So from the issued timestamp, the JSON Web Token will be valid for another 30 minutes. You can set it to any value you want. For example, if you want it to be valid for 1 week, then you can give 7 days option here. So that is the expiration. Now the next thing is we need to set the key. So we need to provide the option for sign with. So we have to sign this JWT payload with a secret key. So that key we have to provide here. So for the key, I will write another function here, private secret key generate key. So we have the key in the encoder format here in this variable. We have to convert that into a secret key object. So that can be done using base64 get decoder decode, and here we can give the secret key. So this will decode the secret key, right? Now the decoded key is going to be a byte array. So let me assign the value to a byte array. So decoded key. And then I need to convert this byte array into a secret key. So for that, there is a keys.class. So keys from io.json web token security, the library we added. So keys.hmac sha key for function can be used. So I will use that and pass the decoded key to convert that decoded key into a secret key. Now I can use the secret key like this generated key to sign the JSON Web Token. Now that I have signed it, I need to convert it into a string format, for which I can call compact. When compact is called, it will be converted into a JSON format we have seen in the introduction. Now we are missing one thing that is called claims. So let me show you why we need claims. So if you look at the introductory example we have used, we have specified all the things like username. So the username is set, the issue date is set, the expiration date is set, and we can also add extra data into the payload like this. So ISS means issuer. So here I have given the http secure.genuinecoder.com, etc. So if you want to add more information, like maybe name of the user. So for us in the example, we don't have any name, so we are not providing that. You can provide those kind of things as claims. So we will be doing that here. For our example, I will provide the ISS value. So for that, let me provide map string, a string map, and let me call it as claims to new hash map. So we'll create a new map, and then claims.put ISS. Then I will provide the URL, whatever URL is issuing the JSON Web Token. So this is just for an example. If you want to add something like maybe name to something like Bruce, you can do that. Okay, you can add extra claims here. So for now, I am only providing this claim, and then the claims can be passed like this claim, and here I can provide the claims. Is there any problem? So claims. Okay, claims. Now that we have prepared the generated token, we can return it like this. So return jwts.builder.claims.issued. Okay, so that is the task. Now the next task is going to be calling this generate token function when a login is requested, or when a special endpoint for generating the JWT token is called, we have to call this function. So for that, let me go into the content controller, and here we have all the endpoints. I will add a new post mapping here. So post mapping, and the endpoint, I will name it as authenticate. Okay. And the function is going to return a string value because this will be returning the JWT token. So public string authenticate and get token. Okay, now I have to receive the username and password here. So I will authenticate with that username and password, and if it is a successful authentication, I will return the JWT key. So for that, I need a new Java class for the username and password form. So I will just create a new Java class here that is going to be login form, and I need two fields, username and password. So for ease of use, I will just use a Java record, and I need string username and string password. So I will just receive these two things. If you are not familiar with the Java record, this is nothing but a simple Java Pojo class. Actually, I can convert that into a Java class itself, convert record into a class. See, this is the username, password, getter, and setter. So all these are automatically generated when you are using the record. So it is just a normal thing. So I will use that login form, request body login form, to receive the username and password. Then I need to authenticate. So for authentication, I need authentication manager. So I need to provide that here. So at AutoWired private authentication manager. So the authentication manager will help us to authenticate by username and password. So we don't have to write the logic separately. So currently there is a problem, and the problem is saying that could not auto-wire because I haven't defined any authentication managers in my code. So first I need to do that. So for that, I will go into my security configuration, and here I have a couple of configurations already done for the authentication. What I need to do next is I need to create a new authentication manager. So public authentication manager, and I already have an authentication provider that is linked to the database class or database service, which is authentication provider. So here I can just use return new return provider manager, return new provider manager, and it should accept a provider. Yeah, authentication provider. So we have an authentication manager now, and I will use that authentication manager to validate the username and password coming from the user. So login form dot get, no, we have the username and password coming here. So what I will do is I will call authentication manager dot authenticate, then new username and password authentication token, and I will give the username login form dot password that is given by the user to here. Then it should give me a authentication result. So an authentication result, authentication. So we will get an authentication result, and we can check if the username and password were proper. I mean, we can validate whether the login credentials were correct using is authenticated method. So if the user provided the correct username and password, we have to return the JSON Web Token, right? So I need to access the JWT service class we have just prepared in this controller. So for that, I will create at AutoWired private JWT service, and then I will use that JWT service here. There is one more error. I haven't specified JWT service as a Spring Boot bean, so I will configure it as at service. So when I do at service, I can auto-wire it to here. So I will use that JWT service instance, and then I will generate the token. Now, the generate token method actually requires a user detail class. So the user detail class is available in the model my user detail service. So there is a function already written. So when we give the username, it will check the database for any user with that username like this. So this is my user class. It will search for the username and get the user object, and if the user object is present, it will convert that into a user detail class. The user detail is actually an interface. So the user detail interface is provided by Spring Security itself. So that interface object is created from here, load user by username. So what I will do is I will call my user detail service class. So at auto-wired private my user detail service, my user detail service. So I can call my user detail service load by username by giving the username from the login form, right? That's right. So that problem is solved. Now I can just return that token and the JWT will be returned. And if the authentication was not successful, then we have to return some sort of error, right? So we will throw new username not found exception, something like that. You can create your own exception here. For simplicity, I am just using an existing exception provided by the Spring Boot itself, Spring Security, that is called username not found exception. And here I will provide invalid credentials or something like that. Okay, I hope this idea is clear. I will just quickly recap through the logic. Whenever the user want to log in, they will make a request to the Authenticate endpoint using their username and password. That will be validated using the authentication manager. And if the authentication is successful, if the username and password match, we will go into the JWT service and issue a new JWT token. All right, now the next thing we need to do is to test this code, right? So the first thing, let us start the code. Let us start the program, JWT application. Okay, now the next thing is we need some users in the database. I will show you the state of my database. So let me load a database viewer. The my user table do not have any data at the moment, so no users are registered. So we will register 2 users first, and then we will call the Authenticate endpoint and make sure that we are getting the new JSON Web Token issued. All right, let me take Postman first. And here the endpoint for creating a new user is /register/user. Let me show you. So if we go into /register/user, it will receive a new user and then it will save it to the database. So we will use that service for creating a new user. So here I will go into the body section and I have pre-filled some data. So I will create a new user with the username admin and a password 9876. And the admin will have all the privileges, right? Like the privilege of a user, privilege of an admin, and privilege of no user. Like a public endpoint will also be accessible. So I will just send a request. And here you can see the admin is created. The password is encrypted and hashed and stored in the database. I need one more user. So I will set the username as user and password a simple one, 1234. And for the normal user, only normal user role is enough. So I will send that as well. So the second user is also created. Let us have a look at the database and make sure that they are here. Refresh. And here you can see we have the admin user, normal user, and they have their proper roles and password is also set. So that is done. The next step is generating a JSON Web Token, right? So here I will go into the Postman again, and I need to make a new request. So the new request is going to be a post request, and then I will connect to localhost 8080/authenticate, right? So in the Authenticate option, I need to provide a body for the login form with username and password. So I will choose this raw JSON option, and then I will pass username as normal user. Let us try accessing as a normal user. So username is user and the password is 1234, right? So I will give the proper credential and let me make the request. And we have a problem. And here you can see when I am trying to access the Authenticate endpoint, I am redirecting to the please sign in. That means the Authenticate is not accessible for everyone. The Authenticate should be accessible for everyone because only then the authentication can be done. So I will go into the security configuration, and here, similar to home and register, I will add Authenticate as public for everyone. So they don't have to have authentication to access that endpoint. So that is fine. Let us start the application again. Go into the Postman and make a request again. And here you can see we have successfully generated the JSON Web Token. So this is the token we can now use for accessing restricted endpoints. So we have been programmed to log in or continue accessing resources using this JSON Web Token, but we have finished issuing or generating new web token when a user is logged in. So I will try some variations. So here, if I give another password like 9876, that is not a proper password, and send a request, you can see I am getting the please sign in page because it is obviously not accepted. So only if I give proper username and password, I am getting the JSON Web Token. So let me try another username as well. So user123, and you can see that is not a valid credential. Now, the last thing we have to do in this session is checking this JSON Web Token validity using the JWT.io tool. So I will paste that here, and here you can see the algorithm is HS512. We have chosen HS512 during the secret key generation. Then you can see our special claim is there, the subject is there, the issue date is 4:44, which is the current time, and it will expire at 5:14 in Indian time. So as you can see, it is generated at 4:44 and it expires at 5:14, which is because we have provided the expiration validity, or the validity of the JWT token is 30 minutes. So that's why the expiration happens after 30 minutes of issue. And here you can see we have the HMAC algorithm set, and once we give the signature, we should be able to validate this encoded data, validate the token. So let me do one thing. Let me copy the secret and then paste that into this section, and here you can see the signature is verified. So for our key, it is verified. Now the next step of this tutorial is we have to validate the JWT token and then allow access to other protected resources. So let's do that next. Now, let us have a look at the different endpoints we have. So we have the /home, /admin /home, /user /home. The /home is accessible for everyone. So if I make a GET request to /home, you can see I am getting the proper response, welcome to home. But both the user home and admin home is protected and requires authentication. So if I try to access user home, you can see I am getting the message, please sign in. If I go to /admin /home, I am getting the message, please sign in. That means it is not accessible. So the idea here is I will first log in using the username and password and get a JWT token, JSON Web Token like this. And I have to use that token with this request, let's say /admin /home, to access the resource properly without a separate login. So that's the idea. That's what we want to implement next. So what I will do right now is I will log in using the admin. So admin account 9876 and generate the web token, JSON Web Token like this. Now I have to use this JSON Web Token for the authorization. So in the authorization section, there is an option called bearer token. So here I can give my web token to access the service. Right now, if I give it, nothing will happen because we haven't programmed our API to accept the JWT tokens. So we will do that next. So one thing to clarify is what will happen when we give the bearer token. So if you look into the header section, you can see there is a new section called authorization created. So the authorization starts with the message bearer space. So no matter where you are sending this request from, you can always add this JWT token using this method. So the header should have the authorization key, and the value should start with the bearer space and then the JWT key. So here in the Postman, it is available as a preset option using the bearer token. So I am using that, but depending upon your requirement, you can always add it manually as the header, authorization header. So now let us see how we can process this header to do the authentication and authorization on our Spring Boot application. So to do so, we need to create a new filter option that will get executed for every request. So for that, I will create a new class and I will name it as JWT Authentication Filter. And I will mark it as a Spring Boot configuration. And then I need to extend it with a once per request filter. So the once per request filter will be executed once for every request. So we can check whether do we need to authorize that request using the JWT token, or we can just process it directly. So the first thing we need to check is the authorization header. So we are sending the data through the header of the request. So I will mark it as string or the header equals request.getHeader, and here I have to provide authorization, so I can get the header value here. And if authorization is not provided, if auth header equals null, or if the auth header doesn't starts with a bearer space. So these are the two cases where the JWT is not properly provided. In that case, we can just continue. So we will provide return, and here we will provide filter. So we have to provide filter chain dot do filter, and here we'll provide request response. So if the request doesn't contain the authorization header, or if the authorization do not have a bearer value, we just ignore that request and continue. So we don't do anything in that filter chain. But if it contains a bearer value, then we have to properly get the JWT value. We have to get the token value. So for that, I will create string JWT equals or the header dot substring, and here I will provide the value 7. So the value 7, the substring 7 is given because the length of the bearer plus space is 7. Here you can see 7 characters. So I will provide the JWT like that. And then I need to extract the username using the from the JWT. So from the JSON Web Token, it contains the details of the user, right? For example, let me take the jwt.io. Here you can see the username is stored inside the subject. So the username is user. So I have to extract that. So for that, what I will do is I will auto wire the JWT service. So JWT service, and then I will write a new function JWT service.extract username, and I will pass the JWT token. So whatever the token is received, I will give it to this function. So I have to create that function here, extract username. So I have the JWT token given here. Now to parse the username, I will use the class JWTS again. And here before we have for generation, we have used the builder option. Now I will use the parser option to parse the data from the web token. So JWTS.parser, and we need to call the function verify with and give the key here. So here the JWTS parser will be prepared with the secret key so that it can verify and read data from the web token. And then I need to call build, and then I need to get the parse option. So parse signed claims, and here I will give the web token here. So JWT is given here, and then I will call get payload. So the response of this one is going to be a claims, and using the claims object, I can actually get the username for the JWT. So for reading the username, I will return claims dot get subject, because remember subject is the username, so we will call the get subject to get the username, and I will convert this into a string function, string return type. So I have the username now, and I will give the username like this, string username equals. So string username equals JWT service dot extract username to parse the username from the token. Now we need to check two things. If the username not equal to null, and the request is not already logged in, we have to make sure that the current authentication is null before proceeding the authentication with a JWT token. Because if it is already authenticated, then there is no need to authenticate with the JWT again. So I will check that like this: security configuration, security context holder, get context, get authentication equal to null. So if authentication is already null, that means it is not authenticated. So the username should be non-null and the authentication should be null. Then what we need to do is we need to find the user with this username so that we can do the authentication testing. So for that, I will auto-wire it here at auto-wired private my user detail service, my user detail service. And from here, my user detail service dot load user by username. So we will give the username parser from the JWT and load the user details of that user. So user details. So now we have the user details object. The next thing we need to do is to make sure that the user details object is not null. So user details not equal to null. And we have to make sure that the token is valid. So we have seen that our JWT token, every JWT token has an expiration date. So it has a validity. Ours is valid for 30 minutes after the issue. So for every request, we have to make sure that this is not an expired token, right? So for that, we need to use another function. So we will write it here, JWT service dot is token valid. So we have to make sure that the token is currently valid. So for that, I will send the JWT string token again, and we need to write a function for that. So is token valid. So to get the expiration date, we again need the claims object. So it is already written here. So what I will do is I will just extract that into a function. So I will just extract that into get claims function. Yeah, IntelliJ nicely converted that into a function for me. So I will give it like this. So first I will get the claims from there. So claims equals get claims, and then I will give the JWT token there. And then we need to make sure that it is not expired, right? So for that, we can do like this. So return claims dot get expiration. So that is going to be a date, and the expiration should be after current date, right? So current date can be created like date from instant.now. So this is again, you have to make sure that you understood this. The expiration date should be in the future. So it should be after the current timestamp. So it should be after date.now or date.from instant.now. So we will confirm the validity of the token like that. And then we need to do some authentication work. So that is going to be username, password, authentication token equals new username, password, authentication token. So we need to create an authentication token first, and then we will pass that to the authenticator. So in the authentication token, we have to give a principal, and that is going to be the username. Then we have to give the password. So the password we can get from the user details object. So user details get password, and then we have to give the authorities, right? So that is also available in the user details object, user details dot get authorities. So we have all the information required for logging in, and then we have to provide authentication token dot set details. I will show this and explain why this line is needed in a moment. Just give me some time. So web authentication detail source, and here I have to build the details into the request. Yeah, and then we need to provide security context holder, get context, set authentication token. So what is happening here is once we make sure that the JWT token is valid, we will create a username, password, authentication token. We are manually doing that. So since the token is valid, we are manually creating a username, password token, and then we are marking the context as logged in. And this one is required because we want to track who is logging into the system. So I will put a debugger point here and then test the code. So let us run our program and see if it is working properly now. So I have put a debugger point here and then starting the application in debug mode. Let's see what happens here. And let me put a debugger point here as well to show you what is happening step by step. Maybe here as well. Yeah. Okay, now let me go to Postman and send the request. See, we have the bearer already added here, so I can just send a request, and we have a problem right now. So the problem right now is it is loading the sign-in page directly without even coming to this portion of the code. That is because we have created this authentication filter, but we have to have it called before the other redirection things are called. So there are multiple filters already running in the Spring Boot. So the JWT authentication filter we just created is not called early enough so that the do filter internal is called. So for that, we need to do one thing. We need to go into the security configuration, and then we need to configure add filter before. And here we have to give the JWT authentication filter. So for that, I need to do an auto wire here. So auto wired private JWT authentication filter. So we are specifying that this filter should be called before what? The username password authentication filter.class. So this is something already provided by Spring Boot. And let me take the authentication filter class now. And there is one problem. So here I have added auth header dot starts with. So the logic here is if the auth header starts with the bearer, I want to proceed. I don't want to return. If it doesn't start with the bearer, I have to return because all the proper JWT authentication requests will have the bearer at the beginning. So I should add a negate symbol there. And then I also need to do the filter so that the request will continue after the authentication. So here the problem right now here is I have added the authentication here in the set authentication, but I am not doing the filter chain. So I need to do filter chain dot do filter, then symbol request and response. So that's enough. Now let us run the program again and see if it works. Let us start that in the debug mode itself so that we can see how each of these lines are executing properly. Okay, I will add a debug point here as well. Then let me go to Postman and we have everything set. Let me make a request. And the request is now coming to the filter properly. It is coming to this do internal filter. So the first thing we need to check is whether the auth header is properly coming. So you can see it starts with a bearer and then we have the JWT here. So we will proceed and we parsed the JWT properly after the bearer prefix, and the next step is parsing the username. So we have parsed the username admin, and then we are proceeding to the database level. So we fetched the user details. Let's see. So we have fetched the username and password for that user. Now we are doing the authentication step, and here I want you to focus. So the thing here that is happening in this line is in the authentication token here currently the details is null, but when we add the web authentication details source.build details step, you can see it added the details of the remote client. So in this example, I am actually running this on my localhost system, and the thing that is making the request, that is the Postman, is also running on my system. So the IP address doesn't really matter. But when you go into the production, you might want to keep track of the clients or the clients who are making this request to maybe doing filtering or spam check or maybe DDoS attack checkup, etc. So this authentication token set details using this class allows you to get the details of the client who is making this request, so that later use from this authentication, like by calling security context holder dot get context dot get authentication, you can get the details of the client, like their IP address, their system information, etc. So that is what this line is for. It is to get the details of the client. And now we are marking it here as like authenticated. So everything should be good now. And you can see the authentication is successful. So we have added welcome to admin home. We are getting the welcome message in the admin section. So let me check it here. If I go into the users home, I should be able to access. Let me remove these debug points because our debugging requirement is completed. So here you can see welcome to user home. So now I am authenticated and I am able to access all the endpoint. Let us confirm this for the user account as well. So currently we have logged in using an admin. Let us try with a user. So I will give the user password as user, username as user, and password as 1234. And then I will generate a JWT here. So the token will be pasted into the bearer section. So it will get updated in the authorization header. And then let me try to access user home, and you can see the user home is accessible. When I try to access admin home, I shouldn't be able to do that. And you can see I am getting the sign in page here. I can access the slash home as well as the user home, but the admin home is not accessible. So that is the proper authorization is also implemented. So that's it, guys. That's how you use JWT to actually gain access to protected endpoints. So I will just recap what we have done here. For every request, we will check whether it has an authorization header. If it has, we will parse the username from that. We will validate the authentication token, JWT token, and then we will set the request as logged in. So far in this tutorial, we have covered the first 4 topics. First, we discussed what is a JSON Web Token and what is its basic ideas. So that is done. We familiarized with the existing project, the sample project I have prepared, then worked on creating new JWT token or JSON Web Token after successful authentication. We also saw how to authorize with a JWT token. So we used an already generated JWT token and then used it to authorize and access some secured endpoints. So that is done. The next thing we need to do is to discuss the signing algorithms. So we have multiple different kinds of signing algorithms. So we will see what each of those are and what is the difference between them. These are the different algorithms available for JWT signing. And here you can see we have 5 different algorithms, 1, 2, 3, 4, 5 different algorithms, and each algorithm have different variations based on the length of the key. So we have used the HMAC 512 option in our tutorial. There is also HMAC 384 and 256 available. So you don't have to understand everything about this algorithm, just an overall idea like when to use which one, etc. So the first kind of classification, the major classification is like what kind of key we are going to use. So here you can see the HMAC is a symmetric type algorithm. It has a symmetric key. That means it has only one secret. So there is only one secret we have used. That is because it is a symmetric algorithm. Whereas the other algorithms, that is RSA, ECDSA, RSA, PSS, and EDDSA, they are all asymmetric. So what asymmetric means is they will have 2 keys, one private key and one public key. So the good thing with the asymmetric option is that you don't have to share the private key if you want others to validate your JWT token. So let me take the browser. So if someone else has to validate your JWT, you will have to share the secret with them. And there is only one secret, right? There is no public key, private key. So this poses the problem of sharing the key. So you can see shared secret key must be kept secure, whereas with the other asymmetric algorithms, there is a public key and private key. And if you want someone to validate your key, you can share the public key with them and they can use the key. But for signing, for generating new private key, they can't do that with the public key. They have to use the private key, which is only available on the server. So that inherent limitation is there for the symmetric key type, the key sharing. It is fast. It is very simple. That's why a lot of people actually rely on HMAC because it is easy to maintain and it is very simple and it is fast. So that is the advantage as well as at the same time disadvantage of HMAC. If you can keep your secret safely, then I would recommend you go with the HMAC, because if there is no one else want to validate your JWT key, and you want to keep everything simple, then go with the HMAC 512. There is 384 and 256 variation, but their strength is less because as the key length decreases, they become susceptible for the attacks, right? So that is the HMAC to 512, and we have used it. When we look into the RSA is an asymmetric option, so is ECDSA and RSA PSS. So from these options, the RSA is an old algorithm actually. It was invented in 1977, and the ECDSA is a better and faster approach than RSA. So if you have to choose between RSA and ECDSA, I would say go with ECDSA because it is a elliptic curve digital signature algorithm, is a recent one compared to the RSA, and it is faster than RSA. So that is a good option. Maybe if you want the most secure option, you can maybe go with ECDSA 512, or you can go with the Edward curve digital signature algorithm. So as you can see here, it was invented in 2011, and it is a newer option, and it is much more efficient. It is very fast and efficient. So if you ask me, like, I want to go asymmetric, what is the best choice do I have? I would say you can go with the EDDSA if your system supports it. So the problem with the EDDSA is, since it is a recently created algorithm compared to the other ones, maybe all systems won't support it because if they are legacy system, they won't support it. So if they do support it, then you want to go with the most secure option, go with the EDDSA. If EDDSA is not an option, go with the ECDSA. And you might be thinking, like, what is with the RSA PSS? So RSA probabilistic signature scheme is not widely supported. There is no specific standard available when compared to the RSA and elliptic curve. So it is not that widely used. And you can see that it is slower than HMAC and RSA and less widely used. So I would not recommend, let me take a pen tool here. So let me mark it. I would not recommend RSA PSS with SHA to SSA. So that is not a good option. So don't think about it. Consider these three algorithms if you want to go with asymmetric. And if you want to go with the symmetric, go with HMAC with SHA 512. So HMAC 512 is pretty secure option. So again, I will just summarize this idea. If you want to go with a symmetric, go with HMAC SHA 512 option, so HS 512 option. If you want to go asymmetric, and if you want to support legacy system, go with the ES 512. If you want to go asymmetric and go with the newer system, and you don't want to support legacy system, go with the EDDSA. All right. I hope you got the basic idea. And if you want to know more, you can even ask AI tools like ChatGPT or Cloud AI, something like that. They will provide you more understandable explanation compared to the other deep articles. So that's about this tutorial. I hope you like this one. I'll see you on the next one. Bye.